Hello and welcome to the Tech Crazy channel. In this video, we shall discuss and learn about the comparators. Introduction. So comparators are meant for to measure the deviation in dimensions. So these are not for the absolute dimensions. So they are employed to find out how much the dimensions of a given component deviate from basic size. Suppose if you take the example that if you are having the any object, circular object, let us say, so which is having dimension of 10 mm. अगर समझो कि 10 mm का एक ऑब्जेक्ट है, सर्कुलर ऑब्जेक्ट. सो अगर आपने माइक्रोमीटर यूज किया, माइक्रोमीटर एंड वर्नियर कैलिपर्स, सो यू कैन मेजर एब्सोल्यूट डायमेंशन, मीन्स एग्जैक्टली उसका डायमेंशन कितना है आप मेजरमेंट कर सकते हैं. सो इफ यू यूज द माइक्रोमीटर और वर्नियर कैलिपर्स, बट by using comparators, so we are going to measure the deviation from basic size, means 10 mm से कितना ज्यादा है कि कम है, that we can measure, but we cannot measure what is its exact dimensions. We cannot measure its absolute dimension. So these are meant for the measurement of डिवेट फ्रॉम द बेसिक साइज. बेसिक साइज से कितना चेंज हो गया, कितना डिवेट हो गया, उस वैल्यू को मेजरमेंट करने के लिए कंपैरेटर्स को यूज कर सकते हैं. सो कंपैरेटर इज नॉट यूज्ड टू मेजर एब्सोल्यूट डायमेंशन. एब्सोल्यूट डायमेंशन मेजरमेंट करने के लिए कंपैरेटर्स को यूज नहीं कर सकते. द स्ट्रेंथ ऑफ कंपैरेटर्स इज, its strength is flexibility, quicker, easier and high accuracy. So these can be used very quickly. This use of the comparators is very easier as compared to the instrument like micrometer and vernier calipers, and these also give the good accuracy. And also skills also not required, not much skills are required. अगर आपको कंपेरेट वर्नियर कैलिपर माइक्रोमीटर यूज करने के मेजरमेंट करने के लिए, देन यू रिक्वायर्ड सम स्किल्स, बट इन कंपैरेटर्स सो इट इज रिक्वायर्ड वेरी लेस स्किल्स. So next is classification of comparators. First one is mechanical comparator. So here just I'm going to explain you classifications so in detail. So we are going to see in the next slides. So first is mechanical comparators. So these works on using mechanical components like gears, linkages, levers, springs, etc. Next is pneumatic comparators. So pneumatic comparator work by using the high pressure air walls and back pressure. So here differential pressure is used for measurements. Next is optical comparator. Optical comparator works by using the lens, mirrors, light sources, etc. So it totally involves the optics. Next is electrical comparator. So electrical comparators works by using the step up and step down transformers. So but that is by using the electrical signals. Next is electronic comparator. It works on by using amplifier, digital signals, etc. Next is combined comparator. Combined comparator, it's a combination of any two above comparators. So that is maybe mechanical electrical, mechanical electronics, electrical electronics, so like that. So it is the combination of any two comparators, so which can give the good results. First let us see mechanical comparators. So this is the dial indicator. So it is most widely used in the measurements of different components in the workshops for inspection of different parts in the workshop. So it is very quick, very easy to use. So here it is a dial, it is also called the dial indicator. that is mechanical comparator you can say. So here you can see, so that it is having two scales. So this one is outside, that is, this is called the primary scale, and may otherwise you can it is also called, it is main scale. So one more scale is there, small needle like, so you can see, so it is called, it is also one more scale. So this this needle, if it is make one revolution, so that means it is 1 mm. So inside needle, if the needle goes from one makes one division, then outside needle will make one complete revolution. That means outside needle, if it makes one complete revolution, it is 1 mm. Inside needle makes one displacement of one division, means from 0 to 1 or 1 to 2, so it will be 1 mm. So it is just like a watch. So how that minute needle makes one revolution, then how a needle make one division, one moment of one division. So same way, so if this one division equals to one complete revolution of the pointer over the main scale, if it makes one division, it makes the one complete revolution, so that is will be equal to 1 mm. That means this plunger will make the moment for this revolutions. When it makes moment during measurements, so this will make the revolutions. So in this way we can use this is for the inspection purposes. So this is very easy one, so you can find in almost all workshops or any industries where inspection is involved. So next is micrometer dial comparator. So it is just like micrometer. So here it is, you can say, so this is the comparators. So here it is, you can say micrometer reading also you can get it exact dimensions. So here you can see that is fixed anvil. So one is called fixed anvil, other is called the movable anvil. So here if you want to measure the any object, if you want to make the inspection of any object, you can place between these two anvils and you can get the results. So this is specially useful for inspection of circular objects. So if you want to measure the diameter of any circular or circular objects, so this will be useful. So next is sigma comparator. So this is very useful when you want to make the measurements of small dimensions. So it will make the magnification. So here you can say this is this plunger. So here workpiece will be kept. When this makes movement, so you can see, so here this will place on this. So you can see, so this is called the arm and this is called the knife edge. And when this plunger makes movement, and this will place on this arm and this will make the movement, and finally this arm, when it makes movement, so this drum is placed on this rope, that is flexible driving band, it is called the band, and this makes movement and ultimately pointer will make the movement. So this is the scale, so reading will be taken from this scale. So here main importance of this is, so it will magnify the measurements. So here this portion is magnified and shown here. So whatever the parts here, so it is shown here. So this is a moving member, that's arm, and it is a fixed member. So here it is, you can say, so this is the pin joint, it will make the revolution like this angular moment about this pin. Next is optical mechanical comparator. So this is a combination of optical and mechanical. So here you can say this is light source. So light source will come by using passing through the condenser lens where light get condensed. So afterwards, so this is the index again. So this will make the light towards in the point form, and then it is projected on the projection lens. And this is, you can say, so here it is a mirror and it is pivoted. So here workpiece will be kept here. Workpiece will be kept on this workpiece. Plunger will make the movement. So here you can see, so this is the lever. So this, whatever the mirror, so this will make the movement when plunger moves on the workpiece. When this make movement, so that will give the reading by using the this scale. Means that light rays will be reflected on the surface on the screen, so depending upon the dimension of the object, so ultimately we can take reading from this scale. So next is optical system of Jasis Ultra. So this is very important from exam point of view also. So this sigma comparator and this Jasis Ultra, so these are most widely asked in the exams. So you can see, so this is also optical, what you can say, mechanical comparator. So here it is a light source and it is a green filter. Means green filter means only green light rays will going to pass this on this. So this is a green filter and this is called a condenser lens. So by this condenser lens, so light will be condensed and this is the lens, and here from this point onwards, so light rays will going to divert and it will going to what you can say, fall on this mirror. So here you can say there are two mirrors, mirror 1 and mirror 2. When the this light rays fall on this mirror, it will reflect it back to second mirror and again reflected back to the first mirror, and then these light rays will be directed towards this point. So here there is a workpiece and this is a plunger. So plunger will make the moment. Means when you want to make the measurements, so you have to make the moment of this plunger on the workpiece. So here this is the eyepiece. So this is the objective lens. So if there is any dimension changes, so that you can see by using the eyepiece, means through the eye. So here you can place your eye and you can take the readings. So this is specially useful where you want to have the high magnifications, so means to measure the small change in the dimensions. So next is pneumatic comparators. So pneumatic comparators are very useful, so for measurements of what you can say, very high accuracy, for very high accuracy measurements. So these are having the very high accuracy. So you can say, so this is here in the pneumatic comparators, so difference in air pressure is used, uh, different difference in air pressure technique is used for measurements. So here you can say, so this is the precision pressure reducer. Means when you want, when you supply some air at pressure, so this will going to adjust the pressure, and this is a non-adjustable jet, so that air will come, whatever the air will come here and here also. So here it is, you can see, so this is the zero setting wall. Means so here you can say this is differential pressure sensor, that is piezoelectric. So this here reading will be taken. So when the air comes here and here also, so here workpiece will be kept. So when the air will strike here also and here also, so whatever the difference between these two pressures, so that will be indicated here. That is differential pressure sensor. So दोनों के बीच में difference pressure difference कितना है वो इधर indicate करता है. So that difference in pressure will indicate the, will help the to make the inspection of the objects. So here if the both are having same pressure, there is no difference between these two, then workpiece is having the proper dimensions. There is no deviation of the dimension from basic size, so whatever the size required. So otherwise if there is any difference, so then that will be indicated here, so that will be, you can record it. So here main concept is difference in air pressure is used for the measurements. So pneumatic circuit diagram for Solex comparators. So Solex comparators, so that is pneumatic comparator. So this is the circuit diagram for the previous whatever we have seen pneumatic comparator. So how this actually works? So pneumatic comparators, you can say, so here high pressure air will be supplied. So here you can see, so here orifice is placed, means this is the actually workpiece which you want to test. Orifice means it is the openings, any opening. अगर एनी ओपनिंग का उसका डायमीटर चेक करने का है, लाइक एनी सर्कुलर ऑब्जेक्ट है उसका अंदर होल है, उसका आप इनसाइड डायमीटर को आप इंस्पेक्शन करने का है, तो यू कैन प्लेस हियर. By placing here, so whatever the air you are supplying, so that difference in pressure will be measured here, means height of pressure proportional to height difference proportional to the pressure. अगर h find किया तो by using rho gh, so automatically pressure will be displayed. So that pressure in difference in pressure will be so again converted into the dimensions. So like this, so we can measure the dimensions of the objects. So main advantage of pneumatic comparators are, so they will give the very high accurate results as compared to the other comparators. Means here you can make the you sometimes it's possible to make contactless measurements. So next is optical comparators, that is profile projector. So this is the profile projector. So we are having this profile projector in our lab. So we are also having the practical on this. That is, we are going to make the measurements, that is linear and angular dimensions, measurement of linear and angular dimensions by using profile projector. So here you can say, so it will I am going to explain during the practicals this one. So how this works, so just I will explain some basic principle how this work. So one, this here it will be light source, so that light source will be condensed, and here the test object, means that is actual workpiece, will be kept, and that light rays will fall on the workpiece, and that this is the projection lens, so that whatever the rays after passing through that test workpiece, so that will be displayed on the screen, and by using the screen, so we are going to make the measurements. That means, so instead of making measurements on the object, so we are going to make the measurements by using its image. So we are not directly going to make the measurement on the object. So this is one of the advantage. So advantage of profile projector is we can make very small measurements also, like 1 mm, 0.5 mm very easily. Suppose if the objects are very, what you can say, soft, like string, rubber, so at that time also, such objects also we can easily make the measurements using the profile projectors. Next is LVDT. So LVDT means it is linear variable differential transducer. So LVDT is based on electrical concept. So here you can see, so this is the primary windings. So this is the primary windings and this is secondary windings. So when there is a primary and secondary windings, so there will be some magnetic field between these two. So when you make the if you want to make the inspection of any objects, means if you want to make the measurement of any object, so you can make the moment of that object between these two windings. So when you make the moment of that object between these two windings, that it will change the magnetic field between these two windings. So that means whatever workpiece, whatever the part you want to measure, so that will be electrically conductive, means only workpieces made up of conductor materials can be inspected by using LVDT. Okay, so by using that magnetic field, so measurements will be done. So these are the different comparators. So if you have any doubts, so important questions out of this normally question will come from the comparators are, so one is sigma comparators, next is Jesus ultra comparators, comparator, pneumatic comparator, and LVDT. So these questions will be normally asked in the exams. So if you have any doubts, so you can personally contact me. So thank you for watching this video. See you in the